Hello and welcome to our next video in the series Programming with Python. Today we're going to be talking about analyzing patient data. The main thing for today is to take the data from the CSV file, upload them into a variable in Python, and then take a quick look at them. What kind of data are we having? So if you remember for the description, so the CSV file, you can think about it sort of like as an Excel table, is a two-dimensional Excel table. And each row means a data for one patient. And in each column, you have the number of inflammation bouts for that patient in that day. So again, it's a two-dimensional array that has rows and columns, like a matrix, if you remember from linear algebra. And we have to store that. So far, we don't know any type of variable we could store it into, right? We know integers, we know floats, and we know strings. So the new type that we're going to introduce today is called the NumPy array or the ND array. This NumPy array comes from a NumPy library. So we start with that. So we will have to first import a NumPy library. Maybe your first question is, what is a library and why do we have to import it? As you recall, I mentioned in the first class that Python is very popular for data analysis because it has lots of ready-to-use libraries. What does this mean is that, like every other language, Python has some core ability. Everyone gets that when they install the basic Python. But when people work with it, they develop a new codes, they develop new functions and new possibilities for the language. And because it would be kind of a waste of the time that every time somebody needs a calculator, they would program a new calculator. Someone who programmed some nice calculator, they stored it in what is called a library. And you can download this library from the repository, you can import it into your Python, and then you can be using the functions and the functionality that this library contains. So NumPy is a shortcut for numerical Python, and this is a library that brings a new functionality for mathematics. There are statistical tools, statistical tools, and so on. But let's say the most important part of NumPy is this new type of variable, and that's the NumPy array. So we're going to talk about NumPy in more depth after we finish this basic course, but we already see that we can use it no problem. So first, to import any library, you need to know the name of the library, like here NumPy, and you just write import NumPy and shift enter. And like this, now the library is imported. For example, now I know that in that library, there is the number pi, right? Nobody wants to remember how much is pi, so there is the number pi there. And if I want to get the pi that is in the library NumPy, I first write NumPy dot pi, and now again I put shift enter, and the pi appears here. This is a classical syntax for calling functions or anything or variables or anything that is in the library. You get the name of the library, then a dot, then the actual thing that you are calling. All right? We will see this pattern a lot, so remember that. Another possibility for importing library is to import it with a shortcut. So we write again import NumPy, and then we write as. And for example, here we put NP. This is a standard, but you can put here whatever you want, SKL. And now I put shift enter. And now what happened is, again, I imported NumPy library. But now to call the NumPy library, I don't have to write the whole word NumPy. I just write KL and .py, for example, and shift enter. And again, I get what is in the NumPy library. So as I said, so typically people call NumPy as NP. You can do whatever you like, but at the same time, I would recommend either you use the whole name, import NumPy, or you use NP, because then if somebody's going to read the code after you, they're going to know right away what it is. And so now we put NP, pi, and we get an error. Name NP is not defined. Of course, I did not run this line of code. So again, I have to run it. And now I can run this line of code, and I get the pi. In the next step, we're going to use a NumPy function called loadtxt to load the data from the CSV file into a variable. So let us call the variable data. So data equals, and for example, normally we would write data equals 5 and it would be an integer. However, what we're going to use is this function loadtxt, which is from the library NumPy, so numpy.loadtxt, and now it has some parameters. The first parameter is we have to put the name of the file that we want to load. So we want to take a look at this file called inflammation-01.csv. As you can see, we store the name of the file as the string. And so here we have another variable fname that equals to this string, and we put this whole thing here is in the function, and we pass it as a value of a parameter. We're going to be talking about functions later more, so if you don't understand this completely, it's fine. Then this function loadtxt takes another parameter, and that is the delimiter. The files that are stored in the CSV, so there's, as we said, that there are rows and columns, so the rows are separated simply by the enter, but the columns are separated by a dash. So we have to put this here like this. So let me double check that I have the NumPy imported so I can use this. And now I'm gonna load from the CSV file. And if I didn't get any error, that means that the data has been loaded. Now let's see what kind of data we have there. So we loaded the data into the variable data. So let us just run that variable. And here you can see. So this is of course not everything that's in the file. This is just this is just a preview. So we see that we uploaded something into it. So next thing is, we already talked about it. So what this loadtxt function does, what type of data is the data? Type data is the NumPy ND array. So that's the ND array, the n-dimensional array that I was talking about before. So at this point, we know that our variable data is an NumPy ND array, but we don't know how many dimensions have that array. Of course, from here, when we see this, we would see that this is a two-dimensional array, but we don't know actually how many rows or how many columns does it have. To find out, you write data.shape, and if I put Shift Enter, we get 60/40. 60 means number of rows and 40 number of columns. So this is a two-dimensional array with 60 rows and 40 columns. So 60 patients has been investigated for 40 days. All right, so now we know that this is a two-dimensional row, and here, this guy here, these are the data for one patient. So this is first row. Then you've got a dash, and then here you've got a second row, and third row, and fourth row, and so on. And the next step, of course, is we don't know what this is, right? We know that we have a container, the array, and we know it has 60 rows and 40 columns, but we actually don't know what these data are. We know what they're supposed to represent, but what they are, what kind of type for Python they are. So what you can write is data.dtype, and we find out that these are float 64. The next thing we need to know is how to access the data in the array. So that means the array is two-dimensional. It has two axes, a horizontal axis and a vertical axis. So the way how you access the data inside of the matrix, how you access each element is the same way like you do it in linear algebra. So this is a first row and this is a first column. So if you had coordinates 1, 1 in linear algebra, you would say this is the element A11, right? This would be the element A12, this would be the element A13. Now we go to second row, so this would be element A21, A22, A23, and so on. However, in computer languages, it is quite useful and widely used to start from 0. So when you're using any kind of coordinates to access something, you start from 0, not from 1. So you have to, if you're thinking in the math coordinates, you have to always subtract 1. So this is a 0th row, first row, and second row. This is the 0th column, first column, and second column. So again, this is an important point to remember, because the coordinates in Python always, for anything, and we will be using coordinates to access lots of data in different data types, you have to know that it starts from 0, and if there is n pieces of data that you want to access, then the last coordinate is going to be n minus 1. So now to actually access the data, the way we do it here, so we write the variable data, and now we use square brackets. And so if we want to access the one on the position 0, 0, so that means in the first row and first column, we just put here 0 dash 0 and shift enter, and that's the value 0.0. And that's the one that is actually up here. Okay. Now, as we already talked about it, so this has a length 40. So if I want to access the last one here, I put here data. I'm still in a first row, but I want to have last column, which is the nth column, but in a Python, it's n minus 1. So I'm sorry. So n minus 1, so it was 40, so 39. And I'm gonna get again, and I'm gonna get this 0, 0. Okay, maybe now this does not look very promising because there is lots of zeros here. But so let us I want to take a look at this guy. So I want this one. So this one is in the first row, third column. So it's gonna be data 0, 2. And you see I got 1, 0. If I want to move, I'm gonna get this guy. So this guy is in the second row, third column, and you see I get 2. So this is an important thing. Remember that always coordinates in Python start from 0, and this is end with n minus 1. If the length is n, they end with n minus 1. As you will see, this is gonna cause you a lot of trouble in future, going through coordinates, going through data types, if you don't remember this rule. So again, looking at this matrix here, if you want to access something, the numbering is the same as in linear algebra. So the next thing we want to do with the data is what is called slicing. So up to now, we were accessing only one entry from this two-dimensional matrix, right? Now, what if we wanted, for example, to access a whole row or a whole column or just part of those? So for that, we use the slicing. So it goes as follows. So similarly as before, you would use this square brackets, and I'm gonna put the dash here, and I'm gonna make some space. And so before, if we wanted, for example, the first guy here, we would put here 0 and 0. But now let me say that I want the first row completely. So what I'm gonna do is, yeah, it's a first row, and now here I want the members 0, 1, 2, and so on. So you could theoretically, you could just list them, but the best way is to do it is with the slice. And for a slice, we are using this double dot. And here we put the beginning of the slice, and here we put the end of the slice. So with the slice, we want to start from the first, so that's 0. And the slice, we want to end with the last one, so that would be 39. But now here, be careful. If you write this slice, So this would mean for the Python to go from 0 to 39. However, it means 0 is included. The element on the index 0 is included, but the last one is excluded. It's up to. So actually this would go up to 38. So we're gonna put here 40. And we do Shift Enter. And now, as you can see, it printed out the whole first row, all the data for the first patient we have. If we now, instead of 40, if we put here 39, we get one less. Okay? So this is another important point. So if you try to call data and 040, so that means the element on the position 040, that's gonna give us an index error, and it says index 40 is out of the bounds for axis 1 with size 40, because so the axis 1, that's the horizontal axis, and there is 40 entries, but because we are starting to count them from 0, the index goes only from 0 to 39. So here you cannot use 40. However, here in the slicing method, you have to go all the way to 40 because this second index here is exclusive. So Python will just go here. So let's try that again. So let me delete this. And so let's say that we want only first 3 entries. So you would want the guy on the position 1, 2, on the position with index 0, 1, and 2. So if I put here 2, see, it gave us only 2, but we wanted 3, right? That is because this index is excluded. So here you have to make it 1 bigger, and now you're gonna get 3. So now we know how to slice, right? How to slice horizontally. And of course, we don't have to start from the beginning. We can start from the second entry and go to, I don't know, 5th entry, right? And second entry, that means actually it's the 3rd entry. I mean the entry with the index 2. So really please be careful about it. The way I'm gonna be talking about it, I might be saying it wrong. So on the index 2, that's the 3rd entry. You see that's 1, and then there would be 3 and then 1, all right? So that's slicing in the horizontal part. Exactly the same way we can slice in the vertical part. So let's say that actually what we want is we want to take a second column, so that's the column with index 1, and let me say that we want to go from the first row to the last row, and there was 60 of rows, so we put 60 here. And now you see this is all the data for each patient from day 2, right? The index is 1, so the day, it was the second day. Now, a little trick I want to show you here is, if you start from the beginning, if you start the slicing from the beginning of the array, you actually do not have to write the 0 here. Without the 0, it's gonna work. And also, if you want to go all the way to the end of the array, you also don't have to write the 60 here. So you can just write here ""-1", and this tells you slice from first to the last row in the column 2. Of course, here you can also, but you can put here some bounds. So for example, maybe you want to start at row 5, but you want to go all the way to the end. So instead of remembering how many rows actually there was, you don't have to write anything. If it goes all the way to the end, you just put this, you just leave this empty. Now finally, you can do both. You can do the slicing in both directions at the same time, right? So let's say I want to go from row 2 to row 5. So I have to put 6 here. Actually 5. Okay. Okay, now this gets really confusing. So yeah, sorry, I have to be really careful about using that word index. So we want to go from row with index 2 to the row with index 5. So that means we have to put 6 here. And now I want to go from column 4 to the column with index 10. So I have to put here 11. And now I run this. And so you see what it gives me is some submatrix, right? If you try to imagine it, I'm just going to cut out like some part of the matrix. So the next step is the first analysis of the data. So in the NumPy, there is many statistical functions that can give us some idea about the data. So the first one we take a look at is the function mean, which gives us the mean of all the data in the array. So again, this is a function from NumPy library. So we have to write numpy.mean, and this function as an argument takes the value of takes the name of the variable. So here we have the data stored in the variable called data, and so the mean value apparently is 6.14. So at this point, let me just stress that not every function have arguments. Some functions have arguments, meaning they have input. You give them some input, like you have a calculator, you give a calculator a number and you tell him what you want to do with it, plus sign, and then it's going to spit out output. So those are the inputs or the parameters. Like here, this function is supposed to calculate the mean, so it needs to know what it calculates the mean from, so we give it some data. We gave it the array with all of this data. Other functions do not need anything, right? For example, here is a function of time. If you want to incorporate time for whatever reason into your program, you can use the library called time, import time, and then you use the function ctime, which is the current time. And as you see, this function here, it has no parameter, it has no input, and it just says what the time is. It's October 1st, 6 in the evening. All right. And so in this function, still, as you can see, it has the parentheses here. So normally, lots of times there would be the input, the parameter in that you have to put in the parentheses. Even if there is no input, you always have to put these parentheses. Look, if I'm gonna delete them, what it does, it says built-in function ctime. And actually what it does is just tells me what the function is, right? I can put a print statement away if you think it's going to be better. No, function time.ctime. So this tells me what the function is. If I add these, now the function is going to work. Our next step is to get more information about the data, getting more statistical information. So we know what the mean of all our data is. Now let us take a look at what is the maximum value, the minimum value, and the standard deviation. So I will not be explaining what the standard deviation is. If you haven't had any course on statistics, I recommend you to Google and find out about that. So here, if we take a look at the code, so it looks slightly different than before, right? Here, what's happening here? Here again, we have the equal sign, which means assignment of value to a variable. What's on the left are all variables. What's on the right are all the values. Here we see functions like max, min, and standard deviation, which are part of the NumPy package. And they are applied to the data. So we can expect that these functions will provide it with the maximum, minimum, and standard deviation value of our data. On the left-hand side, we have variables maxval, minval, and stdval. And in this way, we are defining all these three at the same time. Before, we would be writing something like this, right? We could do it like this. Maxval equals numpy.max data, and that would be, this is how we would define a variable maxval with a value that comes from this function. But what we can do if we want to define several of them at the same time, we don't have to repeat this and again write minval equals numpy.min data. and so forth, we can put them in one line, and we can put here the we can separate them by commas. And so if we separate by commas the variables, and then we separate by commas the values, then that's what we're gonna get. One thing you have to be careful is there has to be same amount of variables as there is of values. So if I delete this value and I'll try to run this, you see I get a value error. Not enough values to unpack. Expected 3 got 2. That's exactly right, like I said. There's 3 variables, so we are expecting 3 values, but we gave him only 2, so we have to add one more. So let me go back, and now I'm gonna run it as it is. And you see we got, and now to distinguish them already, we have more numbers. So we use the print function. Here we put string, maximum inflammation, minimum inflammation, and standard deviation. And here we got the data. So we see we're somewhere from 0 to 20 with the standard deviation of 4.6 and the mean of 6.14. So now we know already something about the data in overall, right, for all the patients. But of course, in our search for some kind of a pattern or for some kind of interesting information, we also would like to look maybe at the patients separately, or maybe we want to look at the days separately. So here comes in play the slicing. So for example, here we can separate the patient 0. That's the patient with the index 0. And so how we separate him? Well, we create a one-dimensional array, which will be just the, like we said in the slicing, it's going to be 0 here, and then we're going to put here the double dot, which means we are slicing from the first column to the last column. All right. So now inside here, now inside of this new variable, patient 0, we have all the data about this patient, and we cut them out from the, or not cut them out, we copy them out from this big array about all patients. And now, for example, we can take a look what was the maximum inflammation for this patient. So again, we use this NumPy function call max. And so now you see that the maximum inflammation for this patient was 18. For all patients, it was 20, but this patient's maximum was 18. If we want to do a different patient, I mean, we can also, again, we can copy the data out into a different variable, or we don't really have to. Like here in this piece of code, we simply run the max function, and the function is just going to run over the data we give it to. So here you see we give it the slice, patient with the index 2, and slice from beginning to the end. And now we find out that this patient had the maximum inflammation of 19. Okay, we could also do averages, right, for each day. So we would like to have something like this. So we would do NumPy mean, and here data, and now we are interested what happens at the given day. So what, for example, so what happened on the first day, right? So all the patients and on the first day, and so you see that the average was 0. So basically nobody had any inflammation on the first day. How about the second day? There were already some inflammation on the second day, more inflammations on the third day. So now, what if we wanted to have these daily averages for all the patients? So of course we could do this manually one by one, but what if we want it for all of them? So for that, we have we can use the following function. So numpy.mean data, and now he write here axis equal 1. And let's see what this does. And so what, oh no, x is equals 0 maybe, no? Yeah, sorry, x is equals 0. So what this does, it does a mean of the data across the given axis. So here, again, going back, maybe here in these pictures, we have axis 1 and axis 0. So the axis 0, that's the rows. That's the rows. Axis 1 is the columns. So if you're doing averaging along the axis 0, that means you're doing averaging along the rows. So that means that for each column, you're gonna do the average over all the rows, over all the rows, over all the rows, and that's what we get here. If you do this along axis 1 is the column axis. So that means you're doing the averaging along the column axis. So for each row, you're gonna do the average. So it's gonna look like this. So you see that some patients, their average was really low, and some patients, their average was a bit higher, though. For example, here, this one had 7, this one had only 5. So this is another important thing to remember. So the first thing is that for this two-dimensional array, we have rows and columns. The way how Python understands it is that rows are along what it's called axis 0, and the columns are along what is called axis 1. If you want to get any element, you have to give the coordinates, which are the indices, and the indices start from 0, not from 1. So this row has the index 2 and this column has the index 2. So this guy here, in normal matrix, this would be index 3, 3, but for Python, this is index 2, 2. And now, as you will see, lots of functions that we will have will be capable to working along the axis, and depending on which axis you give it, it's either gonna go along the rows or along the columns. So let's try another one. So numpy.max, and we give it all the data, to the dimensional data. And again, so let's go along the axis 0. So the 0 axis is the row axis. So that means it's this one. So it goes in each column, you do this along the rows. So that means in this column, the maximum was 0. This column, the maximum was 1. Next column, maximum was 2, 3, 4, 5, goes up and down. If we change this to axis 1, so these are the maximum, so here, these numbers, these are the maxima per day. In each day, the maximum for all patients. Now, if we change this, now this is the maximum of each patient within the given day. So now we are doing it like this. So now we know that this patient over all days, its maximum was 18, this maximum was 18, this maximum was 19, and so on. So it gets in the beginning a bit confusing that you have the rows are axis 0 and columns are axis 1, but when you're actually doing the functions, when you want to, for example, have the informations from the columns, what you're doing is you're summing over the rows. So you have to be summing over the row axis and not over the column axis. So practice that a bit, play with that. As I already mentioned, accessing the data or your variable or parts of your variable using using indices and using slicing is not just for the arrays. For example, we do the same thing for the string. So string, at least for a Python, basically that's a list of individual letters. Yeah, in a very simplified way. It's a list of individual letters, and each letter has an index. And again, the index starts from 0. So if we have this string here, oxygen, it has 6 letters. And so each of these letters has an index. Index 0, index 1, index 2, index 3. And you can access them in exactly the same way as you were accessing the entries in the matrix. So if I'm going to run this code, so you see here I access element, I do a slice from 0 to 3, but 3 is exclusive, so I want elements on 0, 1, and 2, so that means first 3 letters, it gives me first 3 letters. If I want the last 3 letters, I will do 3, index from 3 to 6. 6 is because there is 6 of them, but so that's gonna see the whole thing. So I didn't have to put this here, for example. It's gonna do the same thing. I can also do element, and if I want to access just a single letter, let's say the first letter, I just put here this, and I'm just gonna get string that is on that element, on that index, and that's the string, simply O. So again, so this slicing and accessing with index is not specific just for the, is not specific only for lists or arrays or matrices, but also can be used, for example, for strings, and actually will be used for strings a lot if you be trying to recognize some text, finding a word, or trying to delete a word or something. Sometimes explicitly you're going to be using this indices. Sometimes you will not have to because already somebody wrote some nice function, but nevertheless, it's good that you should understand that the way how Python thinks about these strings is that for him it's just a list of letters where each letter has an index, and therefore when the Python rebuilds the word, it just goes through that list and goes with index from beginning to the end. One more thing that I would like to mention is how to access the elements of a string or a list that are at the end. So for example, let's say that we would want to print the last letter of the word element. Brackets. Okay. So you see, string is out of index. No, sorry, we have 6. So yeah, the last one is 5. Okay. Now you see that to access the this letter, we needed to know what is the last index. The last index is 5. But what if the word is long? Or what if we actually do not know what kind of word is in the element, right? It's a variable. Maybe we are just grabbing words from some word file, and we would want to just get the last letter. So we do not know a priori how long they are, and we would have to first maybe find out how long it is, what is the last index. So for this purpose, what we can use is the negative indices. If we put here -1, see, it gives us n, the last word. If we put -2, we get e, the one before last. And if we put -3, we get the second, the third, or the second before the last, g. So with the indexes 0, 1, 2, 3 up to the final index, you can go through the string from the beginning. If you want to start from the end, you go with the negative indices. As we will see, this is quite useful and powerful, because now we can put anything in the word element. Let's say, so what kind of string we put? We put Kyoso Gakubu, and now I would like to access the last one, and I put -1, and I really don't know how long this string is. I do not know how many letters is here, but I don't need to because I can access it. Or if I want to access the one before. This way of accessing the end of the string we can also use when we are slicing. So for example, let me remind you. So if we wanted to get the whole string, we can just do this, right? We leave the first index and the last index. That means it's gonna go from the beginning to the end, and we get the whole thing. Now we could say that, okay, we want to go from the second index. So we start here, and now we want to go to the end. And again, well, we don't know how long this string is. So let's say we want to go to the 2 before the end. So I'm going to put -3. And as you can see, it works just fine. In several situations in future, you will want to change your arrays. So let's say here we have this we have this NumPy array. So if we look at the definition, so this is one way how to define the NumPy array, is that you just write it down. So you see we have these outside brackets. Here's the beginning and here's the end. And then here you have the first row dash, second row dash, third row. Let me print that to show you. And so now you see again we got a matrix that has 3 rows and 3 columns. Yeah. So here these are the rows, and then of course the columns are formed by the first guy in the first row, the first guy in the second row, the first guy in the third row. So again, it's like the matrices from linear algebra. So we have this 2 by 2 array or a matrix, whichever way you want to call it. What might happen is, so maybe you want to add some data into this matrix. Maybe you have 2 matrices and you want to put them together. And for these, we have these functions hstack and vstack. Hstack means horizontal stack. That means that you want to take 2 matrices and you want to put them next to each other. And you want to create one big matrix. And so let's take a look at that. So now if we see, so what we did here, we used the function hstack, which is from the library NumPy, so numpy.hstack, and here now we put here in the square brackets, we put the matrix A, that's the one we have here, 3 by 3, and we put it again. And so if we take a look at the result, so we see that the one matrix A was put behind the second matrix A horizontally, right? I have one, in the first row I have 1, 2, 3, and then it repeats 1, 2, 3. So it's like if you took A and you write A next to it. And now you have a new 3 by 6 matrix. Or what you maybe want to do is you want to put them on top of each other. So that means you want to stack them horizontally. And that's here. So here we have a vstack function. Again, as you can see, the way how you write it is exactly the same. You just pass the matrix A twice. And now you see that what we got here is that we have the first matrix A, and then we've got the other matrix A underneath. So now we got 6 rows, 3 columns. So we got a 6 by 3 matrix. So the last thing that we're going to talk about today is the function difference. So the data that we have are longitudinal. I mean, it's a horrible word to pronounce, but anyway, the point is that for each patient, you have data from different days. And so what makes sense, so this means that you have a change in time, right? And lots of time you will have data such that they change in time. For example, you're going to have data from a stock market. So you have data of the price of the stock of the first day, second day, third day, and so on. And what you will be actually interested is maybe not the actual price of the stock, but what is the difference, right? Because that's where people make money. Either they sell or buy depending on if the price goes up and or goes down. And that's what you see in the differences of the price, not on actually the nominal value. And so for this purpose, we can use this function difference. So first, we're gonna take patient 3 and look at its data in week 1. So we go to data, it's a patient 3, so that's the patient with the index 3. And now we want to have a first week, so that's from day 1 up to day 7. But we know that the day 1 here, it has the index 0, so we slice from 0 and we put here up to 7 because we know that 7 is not included. So it's going to be slice 0, 1, 2, 3, 4 up to 6, right? Now let us print that. So these are the data. So the first day, 0 inflammation. Second day, 0 inflammation. Third day, 2, then 0, 4, 2, and 2. So, okay. And now if we use this difference function from NumPy on this data, what we get are the differences. So first off, the data we have for 7 days. So we have 7 columns of data, right? We have 7 pieces of data. If we're thinking in differences, we're gonna get one less, right? We have get a difference from first day to second day, that's 0. 0 minus 0 is 0. From second day to third day, that went 2 plus. Then from third day to fourth day, now that decreased, minus 2. Now from fourth day to fifth day, so that increased 4. Fifth day to sixth day, decreased 2. And from sixth day to seventh day, there was no change, so 0. So this is a quite useful function to get the differences if you want to know how things change from one row, from one piece of data to another. Of course, we could do this. We could do this not only over this slice. We could put any kind of slice here. We could do it over what's the change between the patients in one day, but it kind of would make no sense. But you can take any time interval here, right? Let's take the whole thing, and now we see that now we have the data for the patient for the whole trial in the hospital. Now again we run this, shift enter, and now we got the differences. So you see that first, I'm just looking at it, it went up, down, down, excuse me. Then it sort of goes up and down a lot. And in the next lecture we're gonna looking at this, we get some kind of insight, but let's say we are quite graphical, people are. Images that tell us usually much more than text or numbers. So in the next class, we're gonna learn how to make the graphs out of these, so we can see how it goes up and down and what is actually doing, right? You kind of can get lost in the numbers, and comparing this part with this part is like hard. Is this higher, is this lower, right? All right, so that's all for today. So the rest of the information is on the web page. Is here. Don't forget to do all the exercises that are here, and make sure that you understand all the key points. And if you have any problem, then of course during the class time, feel free to ask us about anything from today's class. Okay, thank you, and see you in class.